Hello and welcome to the System Source Computer Museum. I'm Bob Roswell, one of the curators here, and today I'd like to demonstrate our Linotype Model 31. It's a typesetter. I call it our 3,500 pound copy of Microsoft Word. First of all, about an hour and a half ago, our photographer, Brendan, turned the machine on. What we've done is we've melted some lead into the machine. The output of this, just jumping way far ahead, is a line of type made out of lead. We ink this, we put it in a printer, and away we go. So just to show you what's going on here, here's a used line of type. I'm going to put it in the hot pot, and it's melting. You can see that there's about 5 cups of liquid lead in there.
I'll do another one.
Melting. So let's roll the clock way back before 1455. If I wanted a document and I were alive in 1450, I would get out a quill and write it, or if I was rich, I would ask a monk to do it. In the 1455, we got the greatest technological revolution of all time. As everyone knows, Gutenberg invented movable type and the printing press. So just to see how that worked, we would have a box full of type. If we wanted the letter M, we would get out the letter M. We would lay out each of the letters.
There we go. Oh, much better.
Letters lined up. We would ink them. We would put them into a printing press. We would print however many copies we needed. We would take the used pieces, put them back in for tomorrow. As just a small aside, you know why capital letters are often called uppercase? Because the typesetters would go into the uppercase to get out the capital B, and into lowercase to get out the O and the B, and then when they went to write my last name, they'd go back into the uppercase to get out the R, and so forth and so on. So that's the way type was set from the time Gutenberg invented the printing press until Ottmar Mergenthaler moved here to Baltimore in 1880 to revolutionize typesetting. So he sat down, or he formed a company, the Mergenthaler Company, to build a Linotype. So the way this thing works is we start with these little brass mats. Here's a sample mat. This one has a G on it and human readable. The business end of the mat here has the mold for a G in both italic and standard print. And then I want you to notice for later that there is a set of 8 teeth that are on this mat. Anyway, we have mats. We take 1,440 of these and load them into a magazine. So this magazine has 92 channels, timbers. Each channel holds a column of a single letter, E's, T's, A's, I's, dollar signs, everything that's on the keyboard. We need lots of each mat because when I was demonstrating this for the Redeemer Church, the Redeemer, just those 2 words used 5 E's, 1 in the and 4 in Redeemer. We then load on this particular machine up to 4 fonts on the machine. So there's a magazine here. When I close put the sword in to keep them from all falling out, I can crank this, and there's another magazine beneath this that has little 8-point type, and the one before that has 10-point type, and the bottom one has 14-point type in it. When we set out to typecast, we have a keyboard. The keyboard is in an unusual layout. My lowercase letters are here, my uppercase letters are here, and my symbols are here. It's in Etoin Sherdlu. E is the most common letter in the English language, followed by T, A, O, I, N, S, and so forth. So I'm going to turn on the machine, and a couple mats drop down that I hit the keyboard. I'm going to very slowly, because I'm a terrible typist, type V, I, N, T, A, G, E. And my keys got stuck there, so I got a lot of E's. Luckily, I have a spell check light here. So I'll get rid of the others, and I'll deal with those later. And I've written the word vintage. And then I can hit a space. And then I can write computer, C-O-N-T-U-T-E. And that's sticking a little bit, R. And again, we'll fix that up. If I had characters that were not on the keyboard, I would reach over here to my pi characters, and I would just manually insert the character pi or anything else that isn't on the keyboard. So now I have my line, and I'm about to line cast it. So when I go, I'm going to check that nobody has fingers and toes in the way. It's going to come up, over. The elevator's going to take it down in front of the molds. I have 4 different molds, each mold in this at a time. I need a different mold depending upon the width of the line and the height of the line. Then what's going to happen is a piston in the back is going to inject hot metal into the mold, and then a line of type is going to eject over here. Let's try it. Make sure that's over, up, down, over, inject hot metal, rotate, pick up the used mats, put them on the sort queue so that each one of those falls back in and out here. It's very hot, so I'm going to hold on to it. You have a line of type that says vintage computer. Now, of course, it's inside out and backwards because we're going to get a positive of this. I want to point out a couple of really amazing things about this. As I mentioned before, each one of these mats has the 8-bit code on it. So when I type a couple of characters here, and when we go through the cycle again, the arm is going to pick up those used mats, slide them on this binary sort queue, and each one of those is going to fall back in the proper slot. Cool. Brendan, why don't you stay over there and we'll watch the back end of this. So I'm going to type a couple characters, start a line cast, all mechanical. And you can hear or see each mat falling back in for the next line of type. So the Linotype, of course, is our word processor. Word processors don't print. We send the output to a printer. So in this case, what we've done is we've lined up our various lines of type. We've used some coins and some furniture here to put it in a chase. We put the chase in the printing press. This is a Heidelberg windmill press. Put ink on here. This has a pneumatic system that'll pick up a piece of paper, put it up, 40 tons of pressure, and then we get our hard copy. One of the amazing things about this machine is that we got perfect left and right justification. So just like Microsoft Word knows that the M in Mergenthaler is a wide character and L is a narrow character, Word mathematically spreads out all the letters to get the left and right justification. But this is a late 1800s device, and it does full justification. And the question I'll ask of all of you before I tell you the answer is, how does it work? I promise you, I did not count the letters as I was typing this out. I certainly didn't do the math to figure out the width of each letter. Mergenthaler was a genius, but this took him 6 years to figure out a working system. The answer are these space bands. So down here, instead of using a fixed M or N space, I can hit the space band, and that drops down one of these wedge-shaped pieces. So in between each word, when we do full justification, I get a variable amount of space between the words that give me the full justification effect. Pretty neat. So I'm not going to actually ink this up right now because it's a pretty big job, but we'll imagine that our chase is in here. Imagine that we have filled this up completely with ink. We're going to turn it on. We pick up a piece of paper, smash it against there, and all of these pneumatic arms are picking up one sheet of paper, printing it, depositing the final copy over here.